So like I said, we've done the first half of chapter 4, 4.1 through 4.4. Just took a test over it. Now we've got to cover the second half of chapter 4. So today is 4.5, solving polynomial equations. Part 1, because 4.5 is going to take a few days. It's kind of a big chapter. It's got some big concepts that I feel like we need to kind of break down. So 4.5, part 1 today. Solving polynomial equations. So in the past, in Algebra 1, and in this class before, we've used the zero product property to solve factorable quadratic equations. You can extend this technique to solve some higher degree polynomial equations. Can anyone raise their hand and... Yes.
What was the name of the chapter?
There it is. So can someone raise your hand and remind me what the zero product property is? Does anyone remember?
I could be 100% wrong, but is it where you replace a variable with here?
Not quite. That's a good guess, though. That would be to find our y-intercept, which we actually will do that today. But let's say I have something like this. X plus 3 times x plus 5 equals 0. Does anyone remember how I'd solve this? Very good. If I have two things being multiplied together equaling 0, I know one of them must be 0, correct? So I take each factor, set it equal to 0, and solve for x. That's my zero product property. Does that make sense? So here it would be x equals negative 3, x equals negative 5, right? That'd be my two solutions, my two zeros, my two roots, those three different names for the same thing of this polynomial equation. Now, they weren't always in factored form for us. Sometimes we were just given a polynomial like this. And we'd have to factor it and then use our zero product property, correct? So I'd have to factor it and get x plus 5 times x plus 2 equals 0. And then go ahead and use that zero product property. Does everyone kind of vaguely remember that? So here x would equal negative 5, x would equal negative 2. Everyone good with that? Does that concept make sense, that zero product property? If two things are being multiplied together and they equal 0, one of them must be 0. Good? So like it says, we can extend this technique to solve some higher degree polynomial equations. So for example 1, solve 2x to the third minus 12x squared plus 18x equals 0. This is no longer a quadratic. It's a cubic function. And it wants me to solve it. So I'm going to kind of take some of the stuff I've learned in chapter 4 and apply it to this. So what do I need to do first here? Find the greatest common factor. See if there is one. Do I have a GCF here? Yes. Am I always going to have a GCF? No. What is my GCF? 2x. 2x times what gives me 2x cubed? X squared. 2x times what gives me negative 12x squared? Negative 6x. 2x times what gives me 18x? Plus 9. Everyone okay factoring out a GCF? Okay, can anything else be factored here? Yeah, I see. Both of y'all are on the same page. X squared minus 6x plus 9 can be factored further. Don't forget about your 2x. That's got to come along for the ride. What goes in the first spot of my parentheses? X and x.
X minus 3.
Say what?
X minus 3.
Almost there. Don't jump.
X
Don't
minus
don't,
3, X plus 3.
don't jump too far ahead of me real quick. Okay. Let's go slow through this real quick. What are my two signs in this case?
Negative 6 and 9.
Say what?
Is it 9 and negative 6?
I'm saying the signs that go in the parentheses.
Oh, plus and minus. Or
Negative.
They're both negative. If this sign's a plus sign, it tells me they're going to be the same signs. If they're the same, this sign tells me what they're going to be. Okay? So they're both going to be the same based on this sign, and then I know they're both going to be negative based on this sign. Okay? Now, chapter 4, I taught you to use that X puzzle, right? After I had already taught you that, our math department decided that they want to try to go away from the X puzzle. Okay? So I'm going to show you what you're going to see in your future math classes here at Albert High School. It's the same concept as the X puzzle, it just looks a little different.
Oh, I thought you said that they were getting rid of exponents.
No, we're not doing that. So they want us to go to this T-chart method of factoring polynomials. So we make our T-chart. We put our C value in this first spot right here. So 9's my C value. It goes right there. Our B value goes in our second spot. So I'm okay if you still use the X method for right now if you would like. I just want you to see this and know how to do it. Because like I said, in your future math classes, this is how it's going to be taught. We're trying to teach everything the same way. So you see the same thing every year. Does that make sense? So, what are the first two numbers that multiply to give me 9? 1 and 9. In this case, they're both negative, so it's going to be negative 1 and negative 9. What are the next two numbers that multiply to give me positive 9? Negative 3 and negative 3. Is that all of them? Yep. So, like I said, it's the same method as the X chart. It just looks a little different. But this one is nice because it makes you list all your factors of that C value. Okay, whereas with the X chart, we were just kind of guessing. So, after you list out your factors of your C value, we want to add across our rows. So what's negative 1 plus negative 9? Negative 10. Negative 3 plus negative 3. Negative 6. Which two numbers is it? Negative 3, circle it. And I can fill those into my parentheses. Any questions there? Same process as the X puzzle. Looking for two numbers that multiply to give me 9, add to give me negative 6. It just looks different. Okay, how else can I write this? 2x times x minus 3 squared equals 0. Right? We're okay with that? Now, how do I solve this? I don't necessarily need to do that right now. The what? No, I don't have to do that. I'm trying to solve this for x. So at this point, could I use my zero product property? Yeah. One of my factors is 2x. So I'm setting that equal to 0. My other factors are x minus 3. So I set that equal to 0. Do I need to set x minus 3 equal to 0 twice? No, it's kind of redundant. You get the same answer, right? So for 2x equals 0, how would I solve that for x? Divide by 2. What does x equal? 0. X minus 3 equals 0. How do I solve that? Add 3 to both sides. What does x equal? 3. How many 3's do I have? 2. Since this is x minus 3 squared, we would say that 3 has a multiplicity of 2 because it's listed twice. You don't have to say that as part of your answer. Just know that that's what that means. Okay? So my two solutions here are x equals 0 and x equals 3. Any questions with that so far? Everyone good with x equals 0, x equals 3? Can I go ahead and move on? So you don't necessarily have to write all of this. I would definitely write these 2 bullet points down though. But before you sit there and start writing and tune me out, listen up here real quick. Let's talk about this top portion. In example 1, the factor x minus 3 appears more than once. This creates a repeated solution of x equals 3. Note that the graph of the related function touches the x-axis, but does not cross the x-axis at the repeated 0, x equals 3. So here's the graph of our polynomial that we just solved. As it says, notice that at the solution x equals 3, my graph doesn't actually cross it. It just kind of touches it and then goes back up. Does that make sense? And then at x equals 0, it actually crosses it. This concept can be generalized as follows. So when a factor x minus k of f of x is raised to an odd power, the graph of f crosses the x-axis at that value, x equals k. When a factor x minus k of f of x is raised to an even power, the graph of f touches the x-axis but does not cross the x-axis at that value. So on the previous slide, we had 2x times x minus 3 squared equals 0, correct? Is x minus 3 raised to an odd or even power? Even. So before I even saw the graph, based on this concept, I could have predicted that it wasn't going to cross the x-axis there, it was just going to touch it. Does that make sense? Any questions there? This information is going to help us sketch graphs of our polynomial functions. Any questions so far? We okay with the factoring and solving? Yes, no, maybe so? Yep. We just got through a whole few sections, 4 sections of factoring. Hope we're okay with it. Can I go ahead and move on, or are we still writing?
Still writing.
Okay, I'll give you a little more time. So once again, since x minus 3 was raised to an even power, it's just going to touch my x-axis at 3 and not cross it.
What do you mean it was raised to an even power? How do you do that? Okay.
So you see right here, x minus 3, it's raised to the second power, right? Is 2 an even or odd number? Even. That's an even power.
Okay.
So if it was raised to the 4th, the 6th, the 8th,
So
I know it's going to just touch it. If it was raised to the 1st, 3rd, 5th, 7th, so on and so forth, it would cross it.
okay.
Okay? That makes sense? Can I go ahead and move on? Okay. Example 2. Find the zeros of f of x equals negative 2 x to the 4th plus 16x squared minus 32. Then sketch a graph of the function. All right, we get to sketch some graphs here. You guys love graphing stuff, don't you? Find the zeros of f of x equals negative 2x to the 4th plus 16x squared minus 32. Do you guys remember how to find zeros of a function? I set my function equal to 0 and just solve it. So I'm going to take my function. Set it equal to 0 and solve it. What's the very first step when I'm factoring? Check to see if there's a GCF. Do I have a GCF here? What is it? 2. How about we pull out a negative 2 to make our leading coefficient positive? Everyone okay with that? So negative 2 times what gives me x to the 4th? X to the 4th. Negative 2 times what gives me 16x squared? Negative 8x squared. And negative 2 times what gives me negative 32? Positive 16, still equal to 0. Everyone with me? Can I factor x to the fourth minus 8x squared plus 16 further? Yes, I can. Going to create my two sets of parentheses. What goes in the first slot of each set of my parentheses here? X squared, because that first term is x to the fourth. When I multiply that through, I want to make that be x to the fourth, so it needs to be x squared and x squared. What are my two signs in the parentheses? They're both minus. Plus sign right here tells me they're the same. If they're the same, this tells me what they are. They're both minus. How do I factor this? Create my t-chart. What goes in the first slot? Positive 16. What goes in the second slot? Negative 8. So someone raise your hand, give me the first two numbers that multiply to give me 16. Raise your hand. Negative 1, negative 16. Jordan. Negative 2, negative 8. Yes.
4 and 4.
Negative 4, negative 4. Are there any more? No. There are not. So let's go ahead and add across our rows. What's negative 1 plus negative 16? Negative 17. Negative 2 plus negative 8. Negative 10. Negative 4 plus negative 4. Negative 8. So which two numbers is it?
4 and 4.
Negative 4, negative 4. Circle it on your t-chart. Fill it into your parentheses. Can I factor anything else any further?
The square you can combine.
Say what?
The square.
What about the square?
Combine them.
Combine them squared? Let's do something before that. Say that again.
When you do x squared minus 4 squared.
Yep, I can factor that further, can't I? So let's factor that further. How can I factor that? What is it?
I'll combine them. You take the square roots.
Square roots. They're difference of squares, right? So what's the square root of x squared? X. What's the square root of 4? 2. What are the two signs?
One be positive and negative.
One's plus, one's a minus. I can do the same exact thing for my next x squared minus 4. X plus 2, x minus 2. Everyone okay with that? There's just two difference of squares right there. Now, what's a prettier way to write that?
Negative
Plus
2.
2 squared.
I have two x plus 2's, so I can write it as x plus 2 squared. I also have two x minus 2's, so I can write it as x minus 2 squared. Everyone okay with that? Some of you guys were wanting to write it x squared minus 4 squared. I'd go ahead and factor it as far as I can go before I start combining things squared. Does that make sense? Can I erase my work at the top to give myself more room? Okay, now I need to solve this. Set my factors equal to 0. So I'm going to do x plus 2 equals 0. X minus 2 equals 0. How do I solve these? Subtract 2 and add 2. So x equals...
Why wouldn't you do the negative 2 off the front?
That doesn't have an x with it. So that's just like a coefficient for us. That's just going to, since it's a negative, it's just going to flip my graph from being upward to flipping downward. Now if that had an x with it, then I would set it equal to 0. Does that make sense? If it's just a number, that's just like another coefficient. So my two zeros for my function are negative 2 and 2. What's the multiplicity of negative 2? 2, because it's x plus 2 squared, right? What's the multiplicity of x minus 2, or positive 2? It's 2 also, right? They're repeated solutions. They're repeated twice. So I found my zeros. So where is my graph touching or crossing the x-axis? Negative 2 and 2. That's where it's crossing or touching the x-axis, right? Those are my zeros. So now I need to sketch the graph of my function. So I've got negative 2, x plus 2 squared, times x minus 2 squared equals 0. We said x equals negative 2, x equals positive 2. That's just all the information we gathered from solving the equation, right? So I'm going to put a point at negative 2 and a point at positive 2, because I know that's where my graph is either touching or crossing the x-axis. Something else that's going to help me sketch the graph of my function is knowing the end behavior of my graph. So, looking at our original function, is our degree even or odd?
Even.
It's even. Everyone see how our degree is even? Is the leading coefficient positive or negative? It's negative. So I need to go look at my little chart that describes my end behavior. Find the one that says even and negative. Someone want to look that up for me? In your notes, in your book. Our end behavior chart. If it's even and negative.
Like negative infinity stuff?
Yep.
F of x, negative infinity,
F of x goes to negative infinity as x goes to
negative infinity,
negative infinity. F of x goes to
negative infinity,
negative infinity as x goes to positive infinity. So there's the end behavior of my function. So my function is going down as it goes to the left. It's also going down as it goes to the right. Everyone see that? Any questions there so far? Is my graph crossing or just touching the x-axis at negative 2? How do I know it's just touching? Because it's raised to an even degree. It's x minus 2 or x plus 2 squared, right? So I know it's just touching the x-axis at negative 2, not crossing. What about at positive 2? It's just touching because it's also raised to an even degree. Does everyone see that? So I know it's not going to cross. So it's either going to dip down and touch like this, or it's going to dip up and touch like this on both of those. Okay? There's one more piece of information that I need. I need my y-intercept of my graph. How do I find a y-intercept? Does anyone remember? Piper kind of alluded to it at the beginning. Dx. Yep, I'm replacing the x with 0. Because anywhere on the y-axis, that's where my y-intercept is going to be, right? What is my x value always going to be on there? 0. So to find my y-intercept, I can just replace the x with 0 and solve the equation. Well, if I plug 0 in for this first term, what's that first term going to be? 0. If I plug 0 in for the second term, what's that going to be? 0. So what's 0 plus 0 minus 32? So my y-intercept is negative 32. So I'm going to use all this information to sketch my graph. Okay? So since my graph only goes to negative 10 on my y-axis, let's say my y-axis is going by tens. Okay? So this is negative 10, 20, 30, 40, 50, 60, so on and so forth. Okay? So my y-intercept is going to be at negative 32. That's somewhere right in here. And now I can go ahead and sketch the graph. I know it's going off to negative infinity that way. It's going to curve up, and we said it's just touching my x-axis at negative 2, and then curve back down, curve through my y-intercept, curve up and touch the x-axis at 2, and then go off to negative infinity once again. So there's a rough sketch of my graph. Does everyone see how we got that and how we built it? Any questions there? Not too bad? It's kind of a lot, but we've done it all before. We're just kind of adding it all together. Right? Can I go ahead and move on? Here's our assignment. Page 202, 3 through 19 odds. This will be due Wednesday on Canvas. So you got a couple days to knock it out. Okay? Due Wednesday, the 3rd, on Canvas. Go ahead and get this written down so I can put the book page up onto the board. Does anyone have any questions before I stop the recording? Okay, make sure y'all subscribe to my channel. Hit that like button below.